Hey there, everybody. Let's talk about Chapter 2, Population and Health. Most of this chapter actually deals with population and just a little bit of health, but some of the questions we're going to ask I think are pretty interesting. On the other hand, a lot of the material in this chapter is sort of straightforward. Maybe it's connected to issues you've thought about before. Maybe these are issues that have never entered your mind. I'm not sure, but we're going to talk about the population structure, the future of population, the past, and then we'll move on from there, okay? All that to say, there's more than just one question, right? What is the population of the planet? That's an easy one. We're going to try to analyze a little bit and learn some terms along the way. So I have an introductory kind of pre-test that I do in class sometimes with students, but if you're watching this, then perhaps you're in an asynchronous class. If that's the case, then I would ask you to go through and look at these questions on your own and use the lecture slides to find out the answers to them, or Google it or do whatever you want. But this is important information, and it's just a good introduction into, I think, the topic of why population not only is important, but is also kind of interesting, right? So you can see the kinds of questions that we ask for those of us that study population. And this is an area of interest for me as a human geographer. Here are the student learning outcomes, which you don't need to focus on too much. These are more to remind me where we're going, but we're going to think about population as a dynamic system and not just a static one. And we'll look at the relationship between population and the earth, right? The common thread throughout all these chapters, and one of the things that differentiates geography from anthropology is that we always tie these questions of culture and fertility and population growth rates to specific places. And we look at what's going on in those places that might affect any kind of variable like this. And we'll connect these things to migration a little bit, but that will come more in the next chapter, chapter 3. So this is something I always like to look at, and if you're watching this video and we're not doing this live in class, I don't get to take you to the website because I can't capture that screen recording. But if at any time on the lecture notes, if you want to get the link from this slide, you can, or you can look up this population clock, and it's a pretty cool thing. It shows you kind of what's happening, right? All these children that are coming into the world at any given second, and you would see that the U.S. population is growing at a much slower clip than the world population, and hopefully you can read this. There's one birth in the United States every 8 seconds and one death. And since we have more births than deaths, what does that mean for the population of the United States? It means that we're growing, but we're growing very slowly. We're growing well under at 1% per year, and the direction of that growth is actually headed downward because a lot of people are not having children these days. In terms of global population, we just hit the first, we arrived at 8 billion just a few short years ago, depending upon when you're watching this video, that might change. And we're going to hit 9 billion sometime within the next 15 years or so. But it's unclear. The predictions for the future are changing all the time, and that's one of the things we're going to talk about during this chapter. But I would like you to know the most populous countries in the world. India overtook China in 2023 as the most populated country in the world. We've been hearing that that was going to come for a long time, but it happened. And so India's population is growing at a slightly faster clip than China's is. And again, that's something we'll talk about later. The United States is the third most populated country in the world, but just look at the scale here, right? But comparing India and China to the United States, right? The United States is a massive country, but it's still only roughly 1/4 the size of India or China in terms of population. About 1/3 of all people on the planet live in one of these two countries. And actually, the number is even a little bit higher than that. So what else do we have to say about this? We'll leave it there for now. We have a lot to cover today. So here's some student outcomes that I talked about before, and so we can skip those, and here's basically the chapter outline, but I'm going to jump around and sort of deal with the chapter. I'm going to include some things that aren't maybe explicitly explained in the chapter. So let's start with this old guy. His name is Auguste Comte. French philosopher and academic, and he said he's credited with this quote saying that demography is destiny. And you can read the definition of demography here. It's kind of what we're doing throughout this whole chapter, even though we don't use the term much in the textbook. But demography is the statistical study of populations. There's the quote. I got a little bit out of order there. But what he means by that is that if you know the population structure of any place, any country, any town, any community, you can make a lot of judgments about that place, right? So in a place where people have lots of children, that can mean a lot of different things. But what we do know is that if there are a lot of children in a place, you're going to need to build a lot of schools, right? In an area that doesn't have many children today, 20 years from now, you're going to have labor shortages. You're going to have communities that don't have enough workers, and you'll see a lot of help wanted signs. Or maybe you'll see that town start to die because there aren't enough young people replacing the elderly. If you travel anywhere in rural America today, this is what you see, right? The demography of the place has kind of let the place down. Not only have people left and migrated away, but the families that remain haven't had children. And so you see empty schools, empty classrooms, movie theaters that once were full of young people going to movies that are boarded up. And again, this is unique to small town America all across the US. So in many parts of the planet is crowded, right? And maybe you have that concept in your mind, but I want to get into the difference between kind of our preconceived notions of an overcrowded planet and the reality of it. Okay, so this is just a snapshot of all of human history. And there are debates about when humanity began. This isn't really the place to have that debate in this class. We'll go with maybe a couple 100,000 years ago. Some put it at maybe 1,000,000 years ago. But what we do know for certain through archaeological evidence is that for most of our history, we didn't really grow in population as a planet or as a species, right? We have our beginnings in Africa. We know that for sure. I'll talk about that in the next chapter. And we had various clusters of population, but we were hunters and gatherers. We weren't that different from the animal kingdom, right? We were privy to the whims of nature, just like other species. If there was good weather, we might have a few more kids, and we might survive a little bit longer. If a plague came along, we were in trouble, and our population would dip, right? So that's what you see from 10,000 BCE onward, that it's really only with the rise of the advent of agriculture about 8,000 years ago, and then the development of society and cities and understanding how germs work a little bit, right? Beginning to wash our hands and getting away from the dangers that would kill us, that we saw population begin to grow. But the last 200 years are truly unique, right? This is when we experience this massive spike. And so the Industrial Revolution is inherently tied to this massive growth in population that humanity has experienced just in the last few hundred years, right? So we went forever, just sort of maintaining a stable population to hitting our first 1 billion in about the year 1800. You can't quite see it on this chart very well, but you can kind of surmise it, right? So they estimated around 990 million in the year 1800. That's not that long ago, right? A little over 200 years ago. What you also can't tell from this is how many humans have ever lived on Earth. And again, it depends on your definition of when humanity begins and the difference between various kind of pre-human types that we had. But the answer that most who study this would say is that there have been about 110 billion humans, right, that share the same genetic makeup of you and I that have ever lived on the planet. And so today we're at a little over 8 billion, and so that's a pretty sizable percentage of everybody who's ever lived. And I already answered the second question here. A few more questions that are worth considering when we look at this massive population growth. What's the carrying capacity of the Earth? And I think you can understand inherently what carrying capacity means. How many people can the Earth handle? And the truth is that we don't know the answer to that question. Right? People who studied this 10, 20, 30, 50 years ago predicted that the planet wouldn't be able to handle the 8 billion that we have. And some would argue today that the planet is sort of exploding, right? That the impact on resources, given our population, is not sustainable. But it's a question worth pondering. Is the Earth overpopulated? Do we need to shrink in population as a species for the good of all of our futures and for our offspring and for the good of the planet? Again, I don't have an answer for that one, but it's worth considering. So many people think of the Earth and the Earth's population as something like this. And this is a real photo. I would ask you to guess where this is, but you're not going to be able to guess. But you can see how crowded that beach is. You can see what people are doing there. They're vacationing, right? And I'll just tell you where this is. This is in the country of South Korea. And so I'm showing you a population density map. Seoul, Korea is the most densely populated part of the country. And the entire country is densely populated overall, but some places are fairly empty and some places are, you could say, overpopulated. But what you're seeing in the image is an image of a beach on the northeastern coast of South Korea, up here near the town of Sokcho. And if you know a little bit about the culture and the way that South Korea manages itself, you might know this, but you probably don't. And that is this, that Korea tends to give vacation to workers to everybody at the same time, during the same 2 or 3 weeks during the summer. And so what does everybody do that's in the city? They do the same thing that you or I would do. They try to escape the city and they go on vacation and they get in their cars or they get in a bus and they travel the journey, which should only take a couple of hours, over to the eastern coast, to these beautiful beaches. And they try to vacation there. But the problem is that everybody does it at exactly the same time. What should be a 2 or 3 hour journey can turn into 5 or 6 or 7 hour journey. And once you get there, it's packed. Okay, the reason I'm sharing this little tale is because we do the same thing when we try to analyze and understand the population across the whole planet. Sometimes we misunderstand kind of how big the planet really is, how much space there really is, and how many people are out there, right? 8 billion sounds huge. And when you look at the population clock, it just keeps spinning and spinning and adding more people. In some parts of the United States, if you talk to anybody on the street or if you read editorials in the newspaper, you'll hear the same thing. So this is the county from which I'm delivering this lecture right now, Gwinnett County, which is in suburban Atlanta. Those of you taking my class know that. And what you hear everybody talking about is this overgrowth, that we have too many people, that we don't need any more, that we have enough. And people that are living in houses are complaining about apartments that are being built. People that live in apartments are complaining because there aren't enough apartments and that the cost of renting is just too high. So this creates a lot of conflict. The county of Gwinnett is just reached 1 million people a couple of years ago. And so the building just keeps coming and coming and coming and happening. But in other parts of the United States, we're having the opposite issue. As a matter of fact, and if you're taking notes, you might want to write this one down. I mean, you should write down more than this, but I'll just give you that hint. More than half of all of the counties in the United States actually lost population between the year of 2010 and 2020. You can sort of see that on that map. So any county in orange experienced negative population growth. And as you can see, in terms of just the entire land area, that's most of the North American contiguous continent. See the same thing even in Alaska as well. Right? So people are moving away from small towns and from farms and from rural areas. And where are they moving to? They're moving to places like suburban Atlanta, suburban Charlotte, suburban Chicago, and into the cities. Right? But the growth is mostly happening in suburban areas, and we'll talk about that in another chapter as well. So here you can see the data that more than half of counties lost population. Right, so if you travel to those counties, you see a very different landscape. Here's the connection between population change and geography. You see the same things that I was talking about before. You see stores that have closed down. You see bowling alleys with one person sadly bowling by themselves. Right? And you see a lack of infrastructure. You see roads with a lot of potholes because people have left. And when they left, they took their tax base with them. Right? So population is a lot more complicated than people make it out to be. Now, the reality is that there are places on the planet that are so populated that people can hardly move. So this is an image that gets used all the time. This is from the city of, I think it's from Calcutta, India. Don't quote me on that. It doesn't really matter. The principle is the same, right? That people are crowding onto trains, but they're crowding onto trains because they're moving into cities, or they're using it as transportation because they don't have their own. And so India happens to be one of the most densely populated countries on the planet. But again, almost half of the population of India is rural. The other half are densely populated and crowded into small areas and neighborhoods. But if you take any snapshot and use remote sensing data, this is from the great state of Iowa, you'll see it's a completely different story. Okay, so I'm going to tell you something now that you're not going to really believe, but I'm going to tell it to you anyway. And here it is. If you take the entire population of the planet, the 8.1 billion people, and you gather them together, that entire population would fit into the area of Gwinnett County. And not only that, each person would have an area of about 38 feet by 38 feet to stand in. So if you asked them to crowd in even further and just stand side by side, we could fit 16 billion, probably even more than that, just in one county in one country in the United States. So this question of overpopulation gets misunderstood sometimes, right? So we have places that are, you could say, overpopulated, but we have massive swaths of Earth that are really underpopulated and experiencing depopulation in the 21st century on a massive scale. So this is just another version of the image that I showed you earlier so that you can see the connection sort of between historical periods and population growth. And you could kind of think about that, right? And again, these last 2,000 years have been incredibly significant, but even more significant are the last 200 years. Okay, so everybody knows about this hockey stick shape of population growth. It's talked about all the time. But what people maybe don't understand, maybe you already do. If you do, good for you. Is that this is there's something else different going on that's hidden from this graph, and I'll show you in the next graph, which is this. If we look at world population growth rates, right, the rate at which the population is growing has been declining since about 1962. So in 1962, the entire global population was growing at a rate of about 2.2, almost 2.3%, which doesn't sound like that much. But what happened from that 2.5%? It's like having money in a bank account, right? The interest begins to compound over time. And so we experience that massive population growth. But ever since then, the trend line, with a few exceptions since 1962, is that every year the population is growing at a lower rate than it was the year before. So today, in 2025, which is when I'm talking to you, the population growth rate for the planet is lower than 1%. And that's a good fact to know. Again, if you're taking notes, you should take note of that one. And I may have it on here. No, I don't have it listed. So remember that, okay? Population growth rate for the entire planet is a little bit under 1%. The same is true for the United States. So given projections for the world, we're going to hit 9 billion sometime after 2040, and then sometime maybe around 2055, 2060, we'll hit maybe 10 billion. But notice the maybes in here, right? Because we don't know for sure. If we use current projections, this is what the United Nations is predicting. But what we're seeing is a major slowdown from these growth rates. And many countries are now shrinking in population, and we'll get to that in a second. So I'm just throwing this up here again to remind you, and it's something that I would ask you to know, at least the top 5 largest countries by population size, and a little bit about something of their relationship, as I said before, maybe looking at how much larger in population India and China are than every other country in the world by far, right? Because then when you get down to number 3, 4, 5, there's some similar populations here. But of course, the country of Indonesia, much smaller in area than the United States, and yet its population is growing at a much faster clip than the US is. So we have some kind of general rules about human population, at least for most of human history. And that's this, that human populations tend to cluster in certain areas, but they avoid others, right? Some of these are obvious. So human beings look for water. So human population across the planet tends to be near the coast, near rivers, near fertile soil, and they tend to avoid certain physical environments. So remember these concepts of environmental determinism and possibilism that I talked about in chapter 1 again, right? So places like the Arctic, the areas that Aristotle referred to as the torrid zones that humans couldn't live in. But of course, there are some humans that live in the Arctic and in extreme conditions, but very few, right? So humans tend to avoid mountainous lands. Again, there's some exceptions here, especially if you look at highland civilizations of the Inca, right? Massive population that occurred there at one point during their empire. Lands that are too wet, so lands that are too dry, lands that are too wet, lands that are difficult to grow food on have typically been avoided. And yet, if we look at this map again, if we refer to it, right, not only are we seeing that the counties have been losing population, and this is more recent. This is just between the 2 years of 2023 and 2024, so it looks slightly different from that map that I showed you from 2010 to 2020. Okay, you can compare those if you want to go back and forth on the slide deck. But one of the things that we see are that some of the areas of the country that have experienced the most rapid population growth and influx of people have been some of the areas that are most inhospitable to human populations historically, right? So places in Arizona, right, in the desert where there's a huge lack of water, have been experiencing massive growth. The cities of Las Vegas in Nevada and Reno have been some of the fastest growing cities in America. Much of the state of Florida has experienced massive population growth in spite of the fact that most of Florida isn't that great for growing land and it tends to be very hot, right? So in the modern era, in the area of post-industrialism, we're seeing that humans are kind of acting in contradiction to these general rules over time. And we'll see if that lasts, right? It'll be really interesting to be able to come back 100 or 200 years from now and see what Las Vegas looks like, or what Tucson, Arizona looks like, or maybe the city of Dubai, which is also built in a desert, right? Have we sort of overcome the possibilities that seem to be in the limitations that seem to be placed on us by nature, or have we as a population figured out a way to overcome that and continue to have massive populations in Florida? You know, prior to the 1950s, population in the American South was very sparse. Part of the reason for that was because of disease and mosquitoes and heat, right? After the 1950s, we started to see this thing called air conditioning, not just for industrial sites, which is why it was designed, right, but for personal use. Without air conditioning, we never would have had population growth that moved from the north to the south, at least not at the scale at which it did. All right, so there's this connection between technology, between human invention, and where people choose to live. What's coming next? I don't know. That's for your generation to figure out. 2/3 of the world's inhabitants are clustered in just 4 regions. I'm going to keep this one really simple. It's not so obvious on this map, but I've talked about India and China a couple of times, so you know that those are 2 of the clusters. And so I'm just going to list them for you here because it's not quite as obvious as you might think. So East Asia, which encompasses China, the Koreas, Japan over here, is the largest population cluster. And then next we have South Asia, which is dominated by India. So in geography, when we talk about South Asia, we're talking about India and Sri Lanka and Pakistan and Bangladesh, okay, this region right here. And the next 2 aren't necessarily in order, but the next largest population cluster, next of the 4, is Southeast Asia. And that one's not so obvious on this map, right? But Indonesia, as we've seen listed a couple of times, is one of the most populous countries on the planet. But it appears to just be these islands, which are fairly small. Indonesia is comprised of 7,000 islands, most of which are unoccupied at all by humans. But the small number of islands that are occupied are super occupied. All right, so notice Asia, 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 right? And the fourth large cluster that fits in this list is in Western Europe, in here in terms of population. So England and France and Germany, sort of the classic European densely populated countries there. Notice North America doesn't show up here. And so in part, even though we have a major population cluster in many of our cities, it pales in comparison to these 4 population clusters here, where 2/3 of all of the world's population lives. And so, again, for the 3rd time, I'm showing you some data on the largest countries on the planet. Indonesia comes in number 4 and Pakistan number 5. More importantly, of course, some countries are growing in population at a faster clip than others. And so sub-Saharan African countries tend to be experiencing the fastest growth rates, along with a few countries in the Middle East, etc. But in other parts of Europe and Asia and in the entirety of the Americas, with the exception of a couple of countries like in Central America, like El Salvador and Guatemala, we're seeing a negative population growth rate happening there. So notice that there still is a connection between the physical world and population clusters. Right? So we don't want to go too deep into the weeds here, but if you think about the major population centers of the United States, mostly both in the South but also along the eastern seaboard, right? This does happen to be land that is good for agriculture. Of course, not quite as good as the land in the western part of the country, but most of the population in China lives in a particular climate zone. The Koreas and Japan also. But when we look at India, it's a different phenomenon. And so what happens is that people eat different kind of food, right? Obviously rice, because of the physical climate in which people are living. The other thing that's kind of obvious is that people, for the most part, don't live in deserts, right? At least not in huge numbers. So most of the population of the Arabian Peninsula is on the coast, not living inland. The same is true of Australia. Right? So we can look at this in a different way. Maybe you've looked at this map before. There's all sorts of things that we can point out, but I'll be quick, I'll be brief because we have a lot to get to. All right? But on this map, hopefully you can find certain things like I'll just call it the U.S. Western Desert. There's actually a series of deserts in the American West here. And so this is an image of the Earth from at night. But of course, like I talked about in chapter 1, this map is lying to you. Hopefully you know what those lies are a little bit, right? But for starters, you can't see the entire Earth at one time, and it's never night at the same time on the planet, right? The Earth is continually spinning because the Earth is round, in case you didn't know it. The other thing is that this projection isn't entirely accurate because it's distorting certain things, right? So Greenland is bigger in this map than it should be, and some areas appear to be further away than they are. All right, so just a reminder from chapter 1, putting that aside, this is a pretty good rendition that shows you population density, but it shows you more than population density. It also shows you infrastructure development. And we can see some things that are sort of obvious. So let's see. You can hopefully find the Sahara Desert. I'll point it out to you. Hopefully you can see my mouse, right, in North Africa. And what you find is not much infrastructure in the Saharan Desert or the U.S. Western Desert, same thing. You should be able to find the Amazonian rainforest, right, in Colombia, Venezuela, up in here, right? Very low levels of population, and more importantly, low levels of infrastructure. So not much light is being emitted there. What about the Nile River? Can you find that one? We should go back over to Africa and notice, where is all of the population, or most of the population and infrastructure of Egypt? It's right along this ancient river, the Nile River here. And then Alexandria opens up into the delta right here. What else can we find? Can you find North and South Korea? We've got to go over to Asia here. And so you can tell the difference in the levels of development and infrastructure in South Korea compared to North Korea. What about the Himalayan mountains? Where do they sit? They sit right along the northern border here of India and Pakistan, between China and India and Pakistan. And on the other side of these mountains, it's primarily desert, very uninhabitable and very difficult terrain. Okay, and you can see something about the population of China, which is mostly on the eastern side of the country and along river valleys and road networks here. Okay, what else? Anything else worth talking about? Maybe you can see some other patterns. If we were in class, we would talk about those. Here's just a close-up of what North and South Korea look like differently, right? And this is a time lapse, so you can sort of see it, right? But what you can tell is that there's not that much infrastructure development happening in North Korea, even in the 21st century. And the development that is happening kind of in and around the major city of Pyongyang. One cool tool that we have to visualize population across the planet is this thing called a cartogram. It's sort of self-evident what it is and how it works, right? So you can take any attribute and then apply it to a program that tries to maintain the basic shape of the planet, but you can quickly see, this is a population cartogram, you can see how fat India and China get. And the United States is pretty big, but look what happens to countries like poor Canada, right? They practically disappear up here, and Russia as well. So Canada and Russia are the two largest countries by area, but their populations are very, very small. The population of Canada is only around 40 million, right? The countries of Europe get a little bit fatter, and now you can see these population clusters that I was talking about, right? So East Asia, Southeast Asia, and then Europe by far, right? Notice that much of Latin America is not as populated as you might think that it is. Okay, and then it has a lot to do with, again, the terrain, but also fertility rates. Mexico is more populated, right? It has a more dense population than the United States does. So this notion of scale is really important in geography. We talked about it in chapter 1, especially in terms of using a scale on a map. And so most of the maps I use will contain a scale, but not all of them. But another way to talk about scale is the scale of analysis, right? Whether you look at any phenomenon from the point of view of a county level border or a state or a country, right? So if we look at the percent of Hispanics in the United States, that number stands at around 19%. If you look at it by any individual state, New Mexico, for example, it's around 49%, right? Two very different numbers. And you could carve New Mexico up even further into counties, and you would find huge differences between one county and the next. And one county in Texas is 95%. And that might be something that's obvious to you, but the problem is that commenters, talking heads on the news, whoever, might take advantage of scale in order to prove a point that they want. Right? So they might find one county in Texas where the crime rate is really, really high, and they'll use that as evidence to make their case about whatever, about immigration or about law enforcement. And they'll ignore the county that's right next to it or the state as a whole. And this is true of everything. Yeah, so there's a lot more to be said about that, but the reality is that, even when we look at a figure like 19%, right? So we might say, the United States is 19% Hispanic. In your community, there might be 0 Hispanics, right? There might not be a single community anywhere in the United States where the number of Hispanic people represents 19% of the population, right? So an average for the U.S. might mean nothing about any particular place in the U.S. It's just an average. Okay, hopefully you understand that. I think you do. And then we've got some other uses for cartograms, like during elections, right? We always see this map up top, but some people get a little funky and start looking at demonstrating maps according to their electoral value, and California gets really big, and Texas gets really big. Ohio here and Pennsylvania get really big, right? New York gets really big, and Florida gets fat. Right? And so if you wonder why politicians visit the same states over and over again leading up to an election, maybe you've never thought about that, maybe you've never voted yet, but if you have, it's because these states have far more electoral votes, right? The fat states do. And it's also the reason that a presidential candidate almost never visits North Dakota or Montana, right? Because their votes are so tiny. But enough about that one. We can also use these cartograms to demonstrate other sorts of just kind of fun things, just kind of funky things that I wouldn't expect anybody to be able to guess what this map is portraying. It's not population, but you can sort of see that it's related to population a little bit. This is a map that shows, okay, here's a second one, and I should have the labels coming up. Here we go. So the first map is depicted according to gold medals won during the 2024 Olympic Games. And so you notice the United States gets a little bit bigger. Most European countries get bigger than their populations. And then China does really well. And then Russia shows up much bigger. I'm not sure which one. This is Russia right here, I think. The bottom one, no way you're going to guess it. But as soon as I show it, you'll be like, oh yeah. So this is a cartogram of avocados produced across the country. And so the United States gets really small in this one, and look what happens to Mexico. The world's leading producer of avocados by far. And who are they selling most of those avocados to? You got it. They're shipping them across the border to the United States. They're eating a lot of them too. So let's talk about density. This is really straightforward. The number of people per unit of land is arithmetic density, or what you would already think of as population density. And so the places that have the highest population densities on the planet tend to be small, kind of very urban places like Macau and Monaco. And I have some arrows here, right? So Macau is a subdivision of the country of China, and Monaco is a small city kind of municipality in between France and Italy. Singapore, which I talked about before, which is a city-state on the southern peninsula, Malaysian peninsula. And what else do we have? Gibraltar is a small it's a strange kind of political unit, so we don't need to talk about that. And then in Gaza, which is located in the Middle East, here, I didn't put an arrow there. I didn't want to crowd the map too much. The most densely populated larger countries, we have to start with Bangladesh, which is this first arrow, right? Can't go backwards. That's okay. Okay. So Bangladesh right here, and then both Rwanda and Burundi are tiny countries located right next to each other. Huge densities of population. Lebanon in the Middle East, which is right next to the Gaza Strip. Well, it's right next to Israel, which contains the Gaza Strip. And then in Europe, the country of the Netherlands. So if I asked a question about the most densely populated country in Europe, you would say the Netherlands. I won't give you choices between Monaco and the Netherlands because Monaco is kind of a strange thing, right? But the Netherlands is the most densely populated country in Europe. We'll just leave it with that, okay? Physiological density is a slightly different measure. This measures the total number of people per unit of arable land. Okay, so physiological density is really a measure of how well a country can or potentially is able to produce enough food for its population. So notice countries with a high physiological density might struggle to produce enough food for its population, which is certainly true in the countries of India and Bangladesh. But it's also true not just of India, but it's also true of some smaller countries, right? So South Korea and Japan haven't been able to produce enough food to meet the demand for its people in many, many years, right? It's part of the reason why you might hear stories of people in North Korea that are starving or malnutritioned because North Korea doesn't really trade very much with other countries, whereas Japan and South Korea do. The country of England hasn't been able to produce enough food for its population for a long time, for a couple of hundred years, because of massive population growth in the 1800s. This helps to explain in part why England embarked upon so much imperialism and colonialism. It wasn't just about taking over foreign lands. England was looking for stuff. They were looking for food and products and wood that they had sort of overconsumed on the tiny England that they have. A lot of countries in the Caribbean have really high physiological densities as well. But let's move on. Agricultural density is a different measure. It's the ratio of the number of farmers to the amount of arable or farmable land. So a country with a really high agricultural density would mean that they have a lot of farmers, right? You might say to yourself, well, if a country has a high number of farmers, that must mean they have a lot of farmland, and so they produce a lot of food. But you need to change your thinking on this one. Okay, so really a country with a high agricultural density, meaning they have a lot of farmers per unit of farmland, tells you that they're not using a high level of technology to do that farming, right? So more advanced, I mean economically advanced countries have really low levels of agricultural density, like Canada and the United States. And Mexico, we can put in there as well. Most of Latin America has heavily mechanized their agriculture, right? Farm sizes are really, really large. And so the larger that the farm size gets, the more large scale equipment you can use. And so agricultural density is really a measure of technological kind of application of agriculture. And so not really telling you much about how much food is getting produced necessarily, although we can assume that countries with high technology are also producing more food on a unit of land. So notice that that China isn't quite there yet. China is in the process of mechanizing its agriculture, but it still has huge numbers of small farms where people are farming by hand. India is the same thing, okay, and much of South and Southeast Asia the same way. So now let's talk about population change across time. Mostly what we've been looking at so far are just snapshots of population. But let's talk about rates of change and kind of moving forward, looking at what will happen with population next. The easiest way to do that is to look at the rate of natural increase, or RNI, and I talked about it already, the percentage by which a population grows in any given year. And I've given you a few facts and figures, and so I might repeat some of those. But natural increase only looks at births and deaths, the crude birth rate and the crude death rate. So CBR stands for crude birth rate, CDR stands for crude death rate, and RNI represents the rate of natural increase for any given place. And so, as I mentioned before, this number has been falling and falling and falling. Every year, the world is growing in population, but it's growing at a decreasing rate. If you think back to your maybe your calculus class or your trigonometry class, I forget where you learned about rate of increase and the math that's behind that. But nonetheless, the planet is growing, but it's growing at a decreasing rate, right? We reached an inflection point several years ago now, several decades ago. Okay, so when you see that population is increasing, that's true. Population across the planet is continuing to increase, but we can predict with certainty that the population will stabilize during your lifetimes if you're young enough. Probably not during mine. Probably towards the end of my life, the population of the planet will still continue to grow. But by the end of your lifetimes, we're going to see a population on the planet that has either stabilized or might even be shrinking. Here, sometime after 2080 or so. So the RNI for the planet is a little bit under 1%. The RNI for the United States is also a little bit under 1%. Good numbers to have in your brain. Crude birth rate is very simple. The number of births per 1,000 people in the population is the crude birth rate. This is what birth rates across the planet look like. It's probably not surprising to you that we have higher crude birth rates in sub-Saharan Africa. So crude birth rates are very much related to poverty. They're also related to lower levels of women's empowerment. And they're also related to rurality, or the number of people that are living in rural settings, right? People on farms do tend to have higher numbers of children, especially if they are working the land themselves, right? And not using mechanized agriculture. So all these things that I've been talking about are all interconnected. But also keep in mind that it's not entirely a proxy for poverty or income, right? So throughout most of Latin America, we've seen crude birth rates come way down as well. There's something else that explains crude birth rates, but I'm going to hold off on that one when we talk about the next topic. We also see a lot of variability in the United States, with some counties having really low crude birth rates and some having much higher, right? More than double those counties. And there's a few different reasons for it, but we'll hold off on those reasons for now. Let's talk about the next one. The opposite of the crude birth rate is obviously the crude death rate. And there's something more going on with crude death rates, right? So you might say to yourself, okay, just like crude birth rates are related to poverty and women's empowerment and things like that, the same is true of crude death rates. Well, yes and no. Okay, so let's go through this for a second. Right? So you do see high crude death rates in some sub-Saharan African countries, but it's not dominated by only sub-Saharan African countries and a few others in the other parts of the world, like we saw with crude birth rates, right? So one of the things that we see in places like almost all of Europe, in particular Eastern Europe, and then in Russia, is that we have really high crude death rates, in some cases higher death rates in Eastern Europe than in most African countries. So I want to ask you to ponder that question for a second. Why would that be? Your first response might be war. Well, Russia is at war, right, with the Ukraine, at least at the time of this recording. It might, hopefully it won't be for future classes that watch this video. That can account for some deaths, but it's a relatively small percentage of people that die, even when a country is at war, unless it's a massive scale war. Okay? There's something else going on. Can you figure it out? It's sort of a puzzle. I like puzzles. I don't know about you. Why would so many people be dying in Europe and in Eastern Europe? The answer is not quite as interesting as you might think. Right? So it's not disease. It's not falling off of a mountain because they're filming a TikTok, right, or anything like that. There's one very simple explanation, and it's age. Right? So what has happened in many European countries, in particular Eastern European countries, is that they have aged. The percentage of people that are over the age of 65 has become really, really high in countries like Germany and in Lithuania and in Moldova. In part because a lot of the young people have migrated away, but that's, again, a topic for the next chapter. But when you have a huge percentage of older people in your population, what's likely to happen? More deaths. Right? When you're young and you think about death, you instantly think about terrible things like murder and violence and, like I said, falling off of a mountain because you do something crazy, right? Or falling off of a motorcycle, because that's what young people do. But the vast majority of people die because of old age, right? Cardiovascular disease or, something like that. So because the entire planet is aging, we're starting to see a higher number of deaths each year. And this, even though our population is going to start to level off and decrease, we're going to see death rates continue to go up, right? So the natural increase rate is going down, but the number of deaths is going up. And the reason for that is because we have fewer births, more deaths each year. We could also look at the United States, and one thing that this previous projection left out was the spike in death rates that happened between the years of 2019 and 2022. Can you guess what was going on there? If you lived through it, you can. You know this for a fact. Right? So in the United States, we were on a pretty predictable trajectory for death rates that continue to go up. And again, when you see death rates go up, that doesn't mean that the country is becoming more dangerous, right? It means that there are more old people in the population, right? So the United States has that situation too. We'll talk about that in a second. But we did see this major spike for about 2.5 years in the United States. This is entirely COVID, right? I know that there are a lot of people that have a lot of questions about COVID and about COVID vaccines and how effective they were and whether COVID was a real thing and whether hospitals were misreporting data. I don't have answers to all of those sorts of things, but what I can tell you as a demographer and as a human geographer is that during this 2.5 year period, we saw an obvious spike in deaths, right? Deaths in excess of what we would have had otherwise. And there's no doubt about this. There's no conspiracy involved in this kind of data set, right? Somewhere in the neighborhood of 1 million people extra died during the time of COVID. So you can make your own conclusions on that one. We can also see that even though this map is not a map of crude death rates, it's a It's a map of natural increase rate, right, which includes only births and deaths. So this is basically a map of crude death rates and crude birth rates for the year 2022. And usually in class I ask this question. I ask students to think about what places in America you might expect to find the highest death rates. And people will say, I don't know, cities like New Orleans or Chicago or someplace that they associate with high levels of crime. But I've already given this away, but the reality is that most people don't die as a result of crime. When you're young, you're more likely to die from crime than from heart disease. But most people in America die from old age or some complication of aging. And so it might not be surprising to you that the country that it has, the state with the highest crude death rate is, wait for it, Florida. Okay, again, not because it's dangerous, but because there's what in Florida? A whole lot of old people. And old people tend to die at a higher rate.